Okay, so this will be our discussion of the part 2 of module 1. Okay, so included, okay, kasama to sa discussion ng atom. Okay, so at the end of the presentation, students would be able to discuss electron arrangement, explain atomic nomenclature, list and differentiate the atomic configurations. Okay, so basically, those are the three topics that we will be discussing today. So electron arrangement. We all know that electron is one of the subatomic particles that are located in the orbital shells or outside the nucleus. Okay? So the maximum number of electrons that can exist in each shell increases with the distance of the shell from the nucleus. So may specific na arrangement ang electron sa bawat orbits. May maximum capacity ang orbits, each orbits or orbital shell or electron shell, may maximum capacity lang siya kung ilang electrons yung pwedeng mag-occupy doon sa specific orbits. Okay? So, another thing when it comes to electron arrangement, so the number of electrons in the outermost shell of an atom is equal to its group in the periodic table, and it determines the valence of an atom. So may kinalaman yung number of electrons na located or which are occupying the outermost shell. Ano ba yung outermost shell? So depende sa atom. Be it L shell, M shell, or O shell, or S shell. So depende. Okay? So yun daw bilang ng electrons na nag-occupy sa outermost shell ay equal doon sa group ng elements doon sa periodic table. And it also determines the valence of an atom. Okay. Then, the number of outermost shell or outermost electron shell of an atom naman ay equal doon sa period sa periodic table. So, di ba, when we are using periodic table, meron niyang mga groups, period, and family, di ba? So, makikita, according sa electron arrangement, makikita daw sa ating electrons, sa electron arrangement, kung anong family at anong period located yung isang specific element. Okay, so mamaya itatry natin yan. Okay. So, furthermore, sa electron arrangement, okay, meron tayong ginagamit na formula in order to compute what is the maximum or how many electrons, how many maximum electrons can occupy a specific orbital shell. So the formula is 2n squared. So madali pa lang, no? 2n squared. So yung n represents the shell number, which is also known as the principal quantum number. Okay? So remember the formula, 2n squared. Okay, sample problem tayo. Okay, what is the maximum number of electrons that can exist in an O shell? Okay, so O shell. So meaning the O shell is the outermost orbital shell. Bakit? Kasi the innermost shell is the K shell. So mag-start tayo sa K. So K, L, M, N, O. So pang ilang orbits ang o pang ilang orbital shell ang O shell? Pang fifth. Yes, very good. Pang lima. So therefore the formula 2n squared will become 2 times 5 squared. Very good. So magiging ang kanyang maximum capacity is 50 electrons. Okay. So maximum capacity yan ng O shell. Okay. So this is a table na makikita natin yung shell number at yung symbol ng shell as well as the maximum electrons na nag-occupy sa specific shell. So, ang present lang dyan ay the K shell, the innermost. So, I want you to compute. Siyempre, yung O shell natin, alam na natin 50 electrons. So, I want you to give me the maximum electrons that can occupy the L, M, N, P, and Q shell. Okay? So, I'll give you 5 minutes to do that. Okay? So, using the formula 2n squared. Okay, siya nga pala, if hindi pa kayo makapag-avail ng book, you can ask our library, yung ating online library, if you can ask for the uh, online or virtual copy ng uh, ating textbook or particular pages ng ating textbook. Okay, so are you done? So how many electrons or what is the maximum number of electrons for L shell? 8. Very good. How about M shell? 18. Then N shell? 30. 32. Very good. P shell? 72. And Q shell is 98. Very good. Okay, so napakadaling kunin yung maximum number of electrons that can occupy each of the orbital shell. Okay. Basta lagi lang nating tatandaan that the innermost shell ay K. Sa K mag-uumpisa. Hindi sa uh, hindi sa L at masalo hindi sa J, hindi sa A, okay? Sa K. Okay? Okay. So there is another question. What are the period and group for the gastrointestinal contrast agent barium? Okay, barium. So what is the uh, atomic number ng barium. So you can search it sa periodic table. 56. Okay, so 56. So kapag plinat natin siya using the uh, electron arrangement, so anong period at group ang barium? Period 6 and group 2. Okay, so ano nga yung rule? Paano natin malalaman kung bakit siya ay period 6? Period 6 dahil ilan ang kanyang orbital shell? Okay, meron siyang 6 na orbital shell. Okay. At group 2 kasi, yung kanyang electron sa outermost shell ay dalawa. Okay. So, remember yung sa kanina na table natin, it is only the maximum. It does not mean na pupunuin natin yung orbital shells. Okay? So may mga certain rules pa kasi regarding the uh, arrangement ng electron sa orbital shells. So katulad niyan, ito yung pinaka-importante sa lahat na no outer shell can contain more than 8 electrons. So meaning, kung siya man ay O shell, pataas, at siya yung pinaka-outermost shell, hindi siya pwedeng mag-contain ng buong 50 na electrons. Ang maximum lang niya ay 8 electrons. Okay. At kapag meron siyang 8 electrons sa kanyang outermost shell, siya ay considered na stable atom. Okay. Stable atom. Ano ibig sabihin noon? Ibig sabihin noon na siya ay most likely hindi siya makikipag-interact or wala siyang reaction sa other elements or other molecule or atom. Kaya uh, yung ating group ay hanggang 8 lang. Okay. So usually, yung nandun sa group 8, siya yung noble gases. Okay. So the outer shell is always limited to 8. Why? Okay? Because most of the atoms that have one electron in the outer shell lie in group 1 of the periodic table hanggang sa makarating nga sa group 8. Yung noble gases na tinatawag. Okay? Yung binanggit natin kanina. So yan yung reason kung bakit the maximum electron ng outermost shell ay limited sa sa 8 electrons. Okay? So malinaw po ba? Clear? Nagets po? Okay, so do you have questions? Clarifications? Violent reactions? So move na tayo. Okay, so in addition, the orderly scheme of atomic progression from the smallest to the largest atom is interrupted in the fourth period. Okay. So yung fourth period, So instead na ang madadagdagan ng electron ay yung outer shell, dito sa fourth period, yung inner shell ang nadadagdagan ng electron. So yung mga atoms or elements sa fourth period ay tinatawag na transitional elements. Okay. So explain natin yan mamaya kung bakit doon sa inner shell dumadagdag. Okay? Yan. So when an electron is removed from the shell by an X or gamma radiation, photon, so usually, yan yung tinatawag natin na ionization. Okay. So ionization ay removal of an electron sa inner shell by a projectile electron or a photon. So magkakaroon siya ng vacancy sa inner shell. Okay. So yung vacancy na yon sa inner shell ay mapupunan ng electron from the outer shell. So may transition na nagaganap doon sa orbital shells. So yung electron from an outer orbit ay magmo-move papunta doon sa inner orbital shell kung saan na nawalan ng electron. Okay? At tawag dyan ay yung electron cascade. Okay? And yung energy na marirelease ng malilipat na electron ay equal doon sa binding energy ng electron or ng orbital shell. Okay? Okay. At yung energy na yon ay tinatawag na characteristic radiation or Auger electrons. So yung Auger electrons, siya yung malilipat na electron from the outer orbits to the innermost orbit. Auger electrons ang tawag doon. At yung energy na maproproduce sa paglipat ng Auger electrons from its original orbit or shell to the final shell is called characteristic radiation. So we will be discussing characteristic radiation in the coming weeks. Okay, when we discuss the different or the two types of X radiation. Okay? So tandaan lang pag sinabing Auger electron, ito yung electron that moves from an original orbit to another orbit or to the innermost orbit in order to replace the ejected or the removed innermost electron. Okay? So usually yan ay nangyayari sa mga nasa fourth period or transitional elements. Okay? Nakuha po ba yung tungkol kay Auger electron? Okay, so later on, ulitin natin yung discussion about Auger electron with the Auger effect. Okay? So sa ngayon, let us keep focus muna doon sa ating electron arrangement. At dahil sa electron arrangement ay nangyayari sa orbital shells, so we discussed last meeting that the further the electrons or the orbits from the nucleus the lesser the energy. Okay? So meaning, mas malapit ang orbital shell sa nucleus, mas malakas yung kanyang binding energy. Okay? At dito, mayroong dalawang force na involved. Okay, this is the centripetal force and the centrifugal force. Okay, when we say centripetal force, ito yung center-seeking force. This is the force that keeps the electron in orbit. Okay, kaya hindi siya basta-basta maapektuhan ng nuclear pull or ng nuclear force. Okay, kasi meron siyang sariling force na nagkikip sa kanya or yung electron nagkikip sa kanya sa sarili niyang orbit. And each of the orbital shell have their own centripetal force as well as centrifugal force. So flying out from the center force. It is the force that causes an electron to travel straight and leave the atom. So centrifugal force naman, ito yung parang magre-repel or magre-remove sa isang electron kapag siya ay tinamaan ng either projectile electron or photons or electromagnetic photons such as the gamma ray and X-ray. Okay? So, itong dalawang force na ito ay makikita yung dynamics sa atom. Okay? So, ang pinaka-importante dito yung centripetal force because it holds the electrons in its proper orbit. Okay? Then the electron binding energy, so it is the strength of attachment of an electron to the nucleus. So the electron binding energy is dependent upon the orbital shell, kung gaano siya kalayo sa nucleus. And the symbol for the electron binding energy is EB, capital E and small letter B. Okay. So these are some elements that are important to radiological science, okay, or sciences. So tungsten and molybdenum, bakit? Because they are the primary composition or important composition of our X-ray tube target. Okay, so later on you will know what is the X-ray tube target. Okay, bakit ba may target sa X-ray tube? Okay, so that is tungsten. It's made of tungsten. Actually, it's thoriated tungsten. So tungsten with the symbol of W and atomic number of 74, and molybdenum, okay, chemical symbol of MO and atomic number of 42. And yun nga kanina, we have the barium, okay, barium and iodine. They are used for radiographic, fluoroscopic, and CT contrast agent or contrast media. So yung barium, pang ano lang siya, general X-ray and fluoroscopy na contrast media. Hindi siya pwede sa CT scan. So usually ang barium ay yung maririnig yung mga procedure like barium enema, barium swallow, upper GI series, ano pa, esophagography, yan. And then the iodine naman, so usually itong iodine, ang barium ay either pinapainom sa pasyente or pinapasok through the anus. Ang iodine naman, there are 3 ways na ina-administer ang iodinated contrast media. At ito ay through oral, anal, and intravenous. Okay? Then carbon 6 ay important because component siya ng human tissue. So yan lang yung ilan. Okay? Ilan lang yan sa mga important elements. Marami pang ibang elements na importante sa ating profession. Okay. So now we move to the atomic nomenclature. Okay. So nomenclature yung para bang pagbibigay ng pangalan yan. Okay? Sa specific na element. Pero dito, ang pag-aaralan natin ay ano yung chemical symbol, which is the abbreviation of the element, alphabetic abbreviation of the element, and of course, the atomic number and the atomic mass number. Okay? So ano po bang pagkakaiba ng atomic number at atomic mass number? Ano po pagkakaiba? Do you have any idea what's the difference? Okay, so tahimik. Gising pa ba kayo? Baka natutulog na kayo, ha? Okay, so very good, tama. So tingnan natin kung paano siya nagwo-work. At anong kinalaman nito ng atomic number at atomic mass number dun sa tinatawag natin na atomic configuration or nuclear family or families. Okay? So, atomic number, tama, number of protons. Ang kanyang symbol ay Z. Then atomic mass number is the number of protons plus the number of neutrons. And it is always a whole number. Okay? So magkaiba pa yung atomic atomic mass unit, yung AMU. Okay? So, ang symbol naman ng atomic mass number ay A. A, capital A. Capital Z naman doon sa atomic number. Okay. So, the atomic mass number and the precise mass of an atom are not equal. So, yan nga yung sinabi ko kanina na yung atomic mass number, whole number siya, di ba? At yung mass ng atom ay hindi sila equal kasi precise yung mass ng atom. Hindi siya whole number. So mamaya bigyan natin ng example yan. So yan, ito yung example. Katulad ng barium. Okay? So barium, the isotope barium-135, okay? Barium-135 has an atomic mass number of 135 because its nucleus contains 56 protons. Okay, so 56 yung kanyang atomic number. Okay, and 79 neutrons. And the atomic mass of barium-135 is 134.91 atomic mass unit. So hindi siya sakto na 135. So kasi siya ay very precise yung measurement. Kaya sabi, the actual mass of an atom is determined by measurement and rarely a whole number. Okay? So clear po magkaiba yung AMU sa atomic mass number. So only one atom, which is carbon-12, okay, has an atomic mass equal to its atomic mass number. So isang atom lang yung kakaiba. Siya ay illogical, kumbaga. Walang logic. Hindi siya mahanapan ng logic kung bakit siya equal. Equal yung atomic mass, yung AMU niya sa atomic mass number niya. So pareha siyang sakto na 12. Siya lang yung 12. Okay? So siya ay the arbitrary standard for atomic measure. Kaya siya yung ginawang standard sa measurement ng mga atoms. Okay? Carbon-12. Okay, naintindihan po? Nag-iisa lang yan carbon-12. Okay? So it's A and Z are equal. Okay, then elemental mass, it is determined by the relative abundance of isotopes and their respective atomic masses. Ano po ba ang isotope? Have you heard the word isotope sa inyong RT100? Nadaanan niyo ba yung salitang yan sa inyong RT100, isotope? Hindi pa po. Oh, hindi pa. So, isotope. Usually, itong isotope, meron tong naunang word like radioactive isotope. Yan. So, usually, they are used sa ating nuclear medicine. Okay? So, isotope is one of the atomic configuration or nuclear families. Okay? So, later, discuss natin. Ano yung pagkakaiba nung apat na yun? So, protocol for representing elements in a molecule. So, upper left, doon matatagpuan yung atomic mass or atomic mass number. And lower left naman yung atomic number. Then upper right yung valence. Then lower right yung number of atoms. Okay, so tingnan natin. Ito yung example niya. So the X symbolizes the chemical symbol or element symbol. Okay, atomic mass yung letter A. Atomic number yung letter Z. Then number of atoms or molecules. Then the valence. Okay, so itong mga to, mga example. Okay? So hydrogen, okay? Atomic mass number, atomic number. Okay? Atomic mass number, atomic number. Dito is sa H2O, hindi visible yung atomic number at atomic mass number. Alin ang visible? Yung number of atoms, okay? Or molecule. So dito naman, sa sodium chloride, ang makikita nyo is yung valence state. So, positive and negative. Okay? Okay, so let us continue. Okay. Because the chemical symbol also indicates the atomic number. The subscript is often omitted. So subscript, meaning itong nasa baba, omitted down normally. Kaya ito yung karaniwan nating mababasa or makikita na sample ng symbol. So hydrogen, helium, lithium, and uranium. Okay? Hydrogen 1, helium 4, lithium 7, and uranium 238. Okay? So lahat ng nasa taas ay ano ang nasa taas? Atomic mass number or atomic number? Atomic mass number. Okay, so these are the atomic configuration. But before we discuss it, okay, may question ba dun sa nomenclature? Malinaw ba yung kung saan matatagpuan yung atomic mass number, ano ibig sabihin ng atomic number at atomic mass number? Malinaw ba? Kung hindi malinaw, pwedeng magsabi. Huwag mahiya. O kung nahihiya dito, mag-message na lang sa akin. Pwede naman na magkaroon ng special class. Okay? Sige, let us move forward. Mag-move forward na tayo Atomic configuration. So isotopes, ito na nga sinasabi natin kanina, one of the atomic configuration at karaniwan na ginagamit sa nuclear medicine. Okay, so atoms, they are atoms that have the same atomic number but different atomic mass number. So yan lang yung isa sa pinakamadaling definition ng isotope. Okay? Atoms or elements that have the same atomic number but different atomic mass number. Okay? Then isobar, atomic nuclei that have the same atomic mass number but different atomic numbers are isobars. So meaning atoms sila or elements that have the same mass number but different atomic numbers isobar yan. Same atomic mass number, different atomic number, isobar. Same atomic number, different atomic mass number, isotope. Okay? May dalawa pa. Okay? Isotone, they are atoms or elements that have the same number of neutrons but different number of protons. They are isotones. May isa pang meaning or may isa pa akong meaning na ibibigay for isotone. They are atoms or elements that have different atomic number and different atomic mass number. Malinaw isotone, different atomic number and different atomic mass number. Same number of neutrons, but different number of protons. Okay, next, isomer. Isomers have the same atomic number and the same atomic mass number. Okay. Isomer, same, same. Isotone, different, different. Okay. Isotope, different atomic mass number, same atomic number. Then isobar, different atomic number, same atomic mass number. Nakuha? Malinaw? Hindi nakuha. Nakuha ba? Nag-sink in ba? Sige. To further discuss the atomic configuration, imumove ko muna sa kabilang slide. Okay? Okay. So, this is a table about the characteristic of some elements important to radiologic science. So, beryllium, carbon, oxygen, aluminium, okay, calcium, iron, copper, molybdenum, ruthenium, rhodium, silver, tin, iodine, barium, tungsten, rhenium, gold, lead, and uranium. Okay. So, nakalagay na dyan sa chemical symbols, the atomic number and atomic mass number, plus the naturally occurring isotopes. So, meaning, naturally occurring isotope, like barium, okay, let's take barium. Nasa si barium, okay? Yan. Barium have seven naturally occurring isotopes. Okay, so ano yung uh, mga isotopes na to? Barium uh, 1 131. Wait, nakalimutan ko. Basta mamaya, mapito siya. Okay? Tingnan natin kung siya ay isotope ba talaga siya. Okay, so the term isotope describes all atoms of a given element. Such atoms nga, have different nuclear configuration but nevertheless react the same way chemically. Kasi nga, they have the same atomic number. Okay? Yung isotope. So how many protons and neutrons are there in each of the seven naturally occurring isotopes of barium? So ito na nga. Barium 130, barium 132, barium 134, barium 135, barium 136, parang kulang, 2, 4, tama. Barium 137 and barium 138. Okay, so ilan ang protons at ilan ang neutrons? So una muna, ilan ang protons? Malalaman ba agad natin kung ilan ang protons ng barium? Regardless ng kanyang uh, atomic mass number, malalaman ba natin? Malalaman ba natin? Talaga, malalaman natin? So kung malalaman natin, ano ang atomic number ng barium? Ng 7 barium na yan. Anyone who wants to answer? Yung mga 56. Tanungin natin yung mga patay ang camera. Tingnan natin kung they are still awake. Okay, Miss Arate, tulog na yata. Ay, di pala. So, anong atomic number ng barium? Yung 7 barium, pare-parehas ba sila ng atomic number? Lahat. Lahat yung 7. How about for best? Lahat. Okay, thank you. Medroso, lahat. Lahat 56. Okay. So, okay, tama lahat 56. Bakit? Kasi nga, sabi naturally occurring isotopes. Diba? Nandiyan na sa question yung clue na 56 lahat ang kanilang atomic number. Kasi isotopes have the elements or atoms having the same atomic number. So 56. So ang kukunin nyo na lang, hanapin nyo na lang is yung neutrons ng or number of neutrons ng bawat barium isotope. Okay? So paano siya gagawin? So, ganyan lang. 130 minus 56, so 74 neutrons. Okay? Then, yung 132 minus 56, 76. And so on. Hanggang sa 138 minus 56, 82 neutrons. Okay? Okay, nakuha? Okay, that is for isotope. Okay, so yung isobar, okay? So ito yung meaning na binigay natin kanina, different numbers of protons and different numbers of neutrons, but the same total numbers of nucleons. Ano ba yung nucleons? Nucleons are pertaining to, very good, to both the neutrons and protons. Okay, so meaning same atomic mass number but different atomic number. Okay? So isobaric radioactive transitions. So ito ay specific for the isobars. So from parent atom to daughter atom, okay, results from the release of a beta particle or a positron. Okay, ano yung positron? What is a positron? Have you encountered the word positron in your RT100? Na-encounter niyo ba yung term na positron? Po- Positron emission, tomography. Okay? So positron, basically positron is a positive electron. Okay? So, ano naman po, meron po bang negative proton? Yes, meron. Anong tawag? Negatron. Negatron na hindi megatron. Negatron. So, a beta particle ay tinatawag din siyang positron. Okay? So, ibig sabihin, through radioactive decay, okay, or radioactivity from a parent atom, magdi-decay siya into a daughter atom. During the process of decay, magre-release itong atom na to ng beta particle or positron. Okay. And the parent and daughter are atoms of different element. So let's say si parent atom ay uranium. Okay? Kapag siya ay nag-decay, magiging siya halimbawang radon o radium. At during the process of decay, mag-i-emit siya ng beta particle or beta radiation or positron. Okay? Kaya yung positron, it is also a type of radiation. Okay? Clear po ba sa isobar? Okay, clear? Okay, so let us continue. So, isomer. Okay, so they are identical atoms. Okay? So, identical dahil parehas lahat. Okay, so identical atoms except that they exist at different energy states because of difference of nucleon arrangement. So, yun. Nagkakaiba lang sila doon sa energy kasi magkakaiba yung composition ng nucleons. Okay, or ng nucleus. Okay, so yun yung isomer. Okay? May kulang ba? May kulang? Anong kulang? We have the isotope. We have the isobar. We have the isomer. May kulang ba? Meron. Isotone. Okay, so basically, yung isotone ay pareha siyang different. Different atomic mass number and different atomic number. And hindi siya masyadong nagagamit sa ating field. Normally, ang nagagamit lang sa ating field ay isotope. Yung isobar, masyadong ano na siya, mataas na, hindi siya mataas in terms of energy. Actually, yung beta particle, pwede na siya, hindi siya nakakatagos sa wood, ang beta particle. Ay pwede mo siyang harangan or yung beta radiation, tumago ka lang sa likod ng plywood, safe ka na. Hindi ka na ma-expose sa radiation. Unlike X-ray and gamma rays na tumatagos sa wood. Okay? So, ibig sabihin mahina lang yung energy, pero very dangerous ang beta particles. Kasi syempre, kung hindi siya tumatago sa wood, basically hindi rin siya tatago sa katawan ng tao, sa katawan natin. At mag-stay lang siya sa ating tissue. At pag nag-stay siya sa tissue natin, so our tissues will be irradiated and there will be possible consequences or reaction sa ating mga biological elements. Okay? So, let us continue. Or may tanong ba doon sa apat na configuration? Okay? Yes. Okay. When I say mahina, mahina in terms na mas mahina siya kaysa sa X-ray and gamma rays in terms of penetrability. In terms of penetration. Okay. So kapag ang radiation ay, let's say, syempre, ang magiging basehan natin is body tissue, halimbawa. Kasi Sa wood naman, wala siyang magiging effect, or sa paper, wala siyang effect. Pero sa mga biological substances, okay, so meron siyang effect. Okay. So, kung ang X-ray ay tumatagos lang sa katawan ng nagpapa-X-ray, okay, paano natin nasabi tumatagos lang? Kasi may na-form na image. Though, hindi lahat ng X-radiation ay tumatagos lang. There are X-rays that are absorbed by the body. Pero hindi lahat. At the same time, hindi rin siya uh, hindi ganun kataas yung kanyang uh, energy. Okay. So yung sinabi ko kanina, it's energy pertaining to penetration. Ha? Kasi ang beta particles ay mega electron volts. Okay? So kung makikita mo dito, yung sa gamma rays ay kilo electron volts only. So alin ba mas malaki? Mega electron volts or kilo electron volts? Ba mega electron volts. Okay. So kapag siya ay nanatili sa katawan natin, hindi siya tumagos. So maiiwan lang siya doon. And then patuloy siyang mag-i-irradiate o mag-i-emit ng radiation sa particular body part kung saan siya tumama. Okay. Kaya yung PET machine, siya ay calculated, hindi siya basta-basta ginagawa. Dumadaan muna yan sa uh, mga specific calculations with the help of the uh, medical physicists. Okay? Saka ang ginagamit lang sa PET machine natin ay low energy na mga uh, positron. Okay. So syempre, hindi naman lahat ng radiation ay pare-parehas ng energy. Okay? Katulad na lang ng X-ray, there are different uh, range of energy sa X-ray. From 40k kilovoltage hanggang 125 kilovoltage. Okay? So depende yung sa isa-set natin sa machine. Controlled, kasi yun ay controlled radiation. Okay. So usually lahat naman ng radiation ay controlled maliban sa mga naturally occurring radiation. Okay? So nasagot ko po ba ang tanong? Okay, ang pinakamabigat ay alpha. Alpha particle. Alpha particle, pwede mo siyang harangin sa pamamagitan lang ng paper. Magtago ka sa isang papel, hindi ka na ma-expose sa alpha particle. Hindi na siya tatago sa paper. Ganun siya kabigat. Okay? Saka yung kanyang traveling distance ay napaka-iksi lang compared sa sa X-ray at gamma ray. Kasi X-ray and gamma ray travels at the speed of light. Okay, so, yan. Ayan, may clue na kayo sa mga susunod na discussion natin. Okay? So, X-ray and gamma ray ay halos parehas lang sila ng energy. They travel at the speed of light. The only difference is their origin. Okay? So, may question pa ba? May question pa ba kayo? Okay, so kung wala na. So, next is this technetium 99M. Okay? So, this is a radioactive isotope, technetium 99M. Technetium 99M ay ah, anong tawag doon? Nakalimutan ko yung term eh. Ayun, daughter. Imigin ko tuloy baby. So daughter, daughter siya ng ah, ng molybdenum 99. Kaya siya ay technetium 99M. Then, after decaying, magiging siyang technetium 99. Okay, siya ay nag-i-emit ng gamma radiation. Okay, so usually, ito ay ginagamit sa nuclear medicine. Either ini-inject sa pasyente or pinapatak sa, let's say, kung dacryocintigraphy ang gagawin, pinapatak sa mata, okay, para makita kung may blockage ba yung daluyan ng luha. Okay? So nuclear medicine ay can be therapeutic or diagnostic. Okay? So ito yung isa sa mga karaniwan na radioisotope na ginagamit, technetium 99. Okay, there are different uh, types of uh, radiopharmaceuticals na technetium 99, meron technetium 99 DPTA, etc. So, depende yun kung saang organ or body part yung target ng uh, treatment or diagnosis. Okay. So later, yun na i-discuss naman sa inyo when you uh, study for nuclear medicine in your third year. Okay? Okay, so question. Okay, so you have to do this, okay? From the following list of atoms, okay, hanapin nyo or i-identify nyo kung alin dyan ang isotope, kung alin dyan ang isobar at isotone, or kung may isomer ba. Okay, so we have uh, these four elements. Okay. Okay, so I will give you 5 minutes to do that. So meron kayong dalawang iodine. Okay. Bakit dalawang iodine? Bakit kaya? Okay, so 5 minutes. Okay na? Okay. Okay. So, may gusto mag-volunteer ng sagot? Ng kanyang sagot? Tingnan natin. Okay. Iodine 130 and? Okay. 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 Okay, so yung isotope dahil sila ay parehas ng yung dalawang iodine parehas sila ng atomic number. Okay? Then kaya siya isotope, tama? Okay, very good. Then yung sinabi mo kanina iodine 131 plus xenon 131. Okay, parehas sila ng atomic mass number. How about yung last answer mo? Ano nga yung Ano nga yung mga elements na yun? Isotones? Okay. So, sige. Meron bang ibang answers? Meron bang iba? Parehas ba kayo lahat ng sagot niya? Or merong iba? Merong iba? Okay, so tingnan natin yung kung ano sagot. Okay, so the answers are the following. So tama yung kanina sino nga yun? Ay, hindi ko nakita. Sino nagsagot? Si Miss Banyan. Okay, thank you. Okay, so tama yung sagot na iodine 130 and iodine 131 are isotopes because they have the same atomic number, and iodine 131 and xenon 131 are isobars because they have the same atomic mass number 131. Okay? And kulang lang ang sagot ni ma'am doon sa uh, isotone. So, kasama sa isotone si iodine 130. Okay, so iodine 130 and uh, xenon 131 plus uh, cesium 132 ay isotones. Isotones dahil they have different atomic number and atomic mass number. Okay? Tama ba? Okay, so ito yung summary ng ating uh, nuclear family or atomic configuration. Okay? Atomic arrangement. Okay. So basically, you can find this in the book in Bushong. You can find this table in Bushong. Okay, so yan. Okay. So, kung may Bushong na kayo or magkakaroon kayo ng Bushong, I advise you to read the whole chapters. Uh, Yan ay chapter 3, I think. Chapter 3 na yan. Okay. Kasi nilaktawan natin yung chapter 1 and 2. Then, when reading Bushong, kung hindi maintindihan ng isang basa, so basahin ulit. And when also reading the book, pay particular attention in uh, those topics or sentences or phrases na naka-penguin. Okay. Kung kung sa Twitter at Facebook, PM is the key. Kay Bushong, penguin is the key. Okay? So malaking tulong yung penguin kasi most of the time uh, yun yung pinaka-point or yung pinaka-importante dun sa mga nakasulat na paragraphs. Pero nonetheless, it is important pa rin na you read the paragraphs because doon nyo kasi maintindihan kung ano naman yung nasa penguin. Okay? So, Do you have questions before we end the lecture? Okay? May question ba before we end? Anong oras na ba? It's almost 2:30, so abot pa kayo sa quiz. Ano? May question bago mag-quiz? So, ano? Questions, concern? Okay, so thank you for listening to the lecture.